Welcome to our Creating REST Web Services using the Spring framework in our Jakarta Enterprise Edition 8 web application, where we will be using OpenJDK 11 and Tomcat 9. We will start by understanding REST Web Services. In our Introduction to REST Web Services, we will explore how third-party clients interact with Spring Web MVC services for business logic, data retrieval, and persistence. We will focus on service provision and implementation. We will look at our modern context where we will understand the relevance of REST in the age of mobile and Internet of Things, where we enable real-time interactions via client-side JavaScript. Our goal is to learn how REST Web Services facilitates seamless distributed systems integration across diverse platforms for building robust applications. Now let's look at our REST services overview. The definition of REST is an architectural style for designing stateless client-server applications using HTTP. The key characteristics: it's stateless, it's a client-server, it's cacheable, it's a uniform interface and a layered system. Looking at the history, it was introduced by Roy Fielding in 2000. REST grew with the web's expansion and is now widely used for APIs. Our advantages: scalable, flexible, simple, and performance optimized. Our use cases: web APIs, microservices, cloud services, third-party integrations. We will look at how REST provides a simpler approach than the SOAP web services. In our overview, REST offers a simpler alternative to SOAP with flexible data formats, JSON, XML, and plain text, and it uses the standard HTTP methods for CRUD operations, the post, get, put, and delete HTTP methods. The key differences: REST does not require predefined resource formats and uses HTTP protocols directly, making it more adaptable. REST uses HTTP status codes and MIME types. It does this to manage requests and responses, providing clear communication and flexibility. REST has discoverability via HATEOAS, which supports dynamic client interactions, enhancing flexibility in agile and cloud-based environments. Now we get to the part where we actually look at our code and how to configure REST using Spring MVC. We will learn how to extend our existing charity registration application to include RESTful web services using Spring MVC. We will create a separate DispatcherServlet for our REST controllers to keep the web UI and REST components distinct. We will segregate our controllers to maintain separate contexts for web and REST controllers for a cleaner architecture. We will develop our REST controllers and we will implement them to handle JSON and XML requests. We will also implement error handling, where we will incorporate proper error handling for robust REST web services. Now we'll dive deeper into segregating our controllers with stereotype annotation and package organization. Our key strategies is to use different package names where we organize web and REST controllers into separate packages to avoid dispatcher servlet overlap. We will use Spring meta annotations. We'll create custom annotations for web, the @web controller, and REST at REST API control. For cleaner segregation configuration, we'll set up separate web servlet context configuration and REST servlet context configuration for optimized context-specific setting. Now we look at handling error conditions in REST. We will learn how to provide meaningful error responses in Spring REST services using modern error handling techniques. These are the key techniques. We will be changing HTTP response code. We use @response_status and @exception_handler to return appropriate HTTP status codes like 404 for not found or 500 for server errors. For global exception handling, we use @controller_advice for centralized exception handling across multiple controllers. And then we also use custom REST annotations to standardize and simplify controller configurations while handling errors efficiently. And finally, we will be looking at improving discoverability with an index endpoint. We will learn how to enhance our charity registration API's discoverability by creating an index endpoint that lists all available API endpoints with brief descriptions. The key benefits are improved discoverability with a centralized overview of available API operation, self-documentation. This acts as live, self-updating documentation for developers. Ease of use. It simplifies understanding and integration of the API, and it supports versioning, easily adaptable for API versioning, version details included. And that concludes this tutorial. I will see you in the next one.